and then you remove
The new
it.
recording is
That,
already going, so
oh
we're
man,
just
I'm not gonna
recapping though.
explain it
No, yeah,
again.
but
I
we're just
know.
recapping. This is pretty straightforward.
Okay.
We don't have a problem.
All right. So last week we learned how to make comments like macros with expressions. So we learned about variadic arguments that we need a parentheses. Uh, we defined the structure, the base structure at least in brackets.
Yeah, and then
We
F
made the
map.
dummy parser, and then we made a map.
Yeah, now we need to make the
So
bind.
with pattern matching and all of that.
Yeah.
Okay. So let me just run this so we can see running, so you can see the action. There it is. So we have the success, which is DF, and then we have a bound input, which
Yeah,
is 1, 2, 3.
yeah, it makes sense.
All right. So let's do the oopsie. Let's do. Let me activate company mode. I think we can have some use here. Yeah. Okay. So parser. We're gonna do bind now. I think the bind will go fine. I just think. Okay, so what we need to do in the
Can we
bind?
can we can we just do the type signature first, because that's so much more that's so much easier than doing it like by head, like by memory.
So let's think here. So the signature would be a function.
Yeah, I only know in Haskell, so go on.
Um, you will take a t, and the t. It's quite cursed to do like like F sharp. What do I? You got it. That,
It's totally cursed, but okay.
and then we take a parser. Well, I don't think I need to. Parser that takes t. And
Yeah,
when did I put
yeah,
beam? T. Ooh,
yeah.
that's it. And then the
The
result
result
of
should be a
this
parser of uh should be
B.
parser u, right? I guess.
Yeah, parser of U. Yeah,
Yeah.
of B parser. Ooh, that's it.
Yeah, that's pretty much what we want.
So let's just add here. So
F
we're using
and
F
F
here
and a
and
parser.
parser.
Yeah. And by the way, did you discover if this sort of documentation works?
I don't know if it shows here.
No, no, no.
We
But
can try
can you
because there
compile?
is. Oh yes, it compiles like this. It compiles.
Are you sure?
Yes,
I think we tried that.
it
It didn't
does.
work.
It no. We tried this.
I
This
agree.
is not the correct documentation because this is a record. It's understanding as a field, but on functions it works.
Oh, okay, okay, makes sense then.
Okay,
Okay,
so what we want to do is make
it's exactly same structure as the other one. Like make
yes.
parser run.
So
Someone is
run.
here,
Who
and
is
I don't
there?
know. I don't
Nothing.
know. Show members. Oh, Nathan is here. Hello, Nathan.
Nathan has joined the party.
Hello, hello.
All right, so we're gonna get the input, which is the new function,
Nathan, we are
and
now
then
making the bind function for the parser record-ish. Just so you to
Okay.
know.
mhm.
We have
So
the
how
parser
is the
map, which is basically the functor or f map or map, whatever you want to call it, and now we're making the bind.
so the bind is kind of different because we need to apply the function to the f to the thing apply f to the thing inside the parser after running with the input, and then from that guy we basically get the run function and we run it over the new input that was produced via the
Well, I
parser.
think
Correct?
there are two ways of doing this then. We can
So let's.
pattern, yeah, because one way is to use parser map to apply the function f inside the other guy.
I think it's gonna be the same structure, yeah. But let's do this next, which is the next input phone call, and we're gonna call parser run. So far the same thing. We can
Yeah,
abstract that
parser.
of the parser with the input,
Yeah.
and then here we're gonna do case next. Oops, let me just do like this so we don't lose the track. And then here we're gonna have to match tuple
New
of the
input.
new input with the case of success
Yeah.
and the value. So far, so good. And then here, we're gonna actually have to do something that is just running. So it's gonna be phone call
Mhm.
of, oops, parser run of the new thing that we are gonna do, which is phone call.
Holy crap!
Uh,
Wait.
yeah, this is gonna be very
I
weird, right?
think
I
I, th-
should
I think
bind
we're no,
this.
but I think we can just use parser map, man. We don't need to do all of this.
Yeah, but I want to see the structure, man, first.
Okay.
Let me think here. So we need to phone call f over the value that is inside. So so this the same thing up there. But then this is also a parser, so we need to apply now.
Wait, how do you know
Well,
that
getting the
fun call
phone.
f? Oh, this is also a parser. Makes sense. Makes
Yeah,
sense.
but we need to apply now to the new input.
Yeah, that also makes sense.
So that's it, I think. So this is already a tuple, the result, so we don't have to do anything. On the other case, however,
Failure, and we have a
failure
message, and then we just,
message.
well, pass that on. I think.
And then, yeah, in this case, we just do like we were doing there. So
Yeah.
tuple. Oops, I keep doing F sharpisms. Uh, and then we propagate the failure with the message. That's it, I think. Let me just see if this works, man.
Yeah. No, if this works, freestyle. Totally freestyle.
Oops, let me do this because I think it's better to read.
That compiles.
It
Definitely
doesn't go up.
compiles.
Yeah, but compiling is not much of a it's
No,
not
but that
much of
was
a
not happening
guarantee,
last
right?
time around. So.
Oh yeah, it wasn't. So parser run, we want to grab the thing, uh, passing down. We're gonna bind,
Yeah, but we need to
correct?
define the function. Okay, the function can be this one. That's no. No, wait. We
Parser.
need to wrap
Yeah,
that. That lambda needs to be wrapped.
this lambda
Yeah, because it's a
does.
thing that it needs to return as a parser, right? The function.
Oh yes, that's true.
So it should be
So
a
this
function that takes an
thing,
x and wrap the def. Apply
yes,
wrap on
that's
that.
yeah. The signatures would help here. So let's see. So we take. So let's see. The signature of f is take a t and transform it to a parser u.
Yeah, just
So let's
wrap
just see.
def. Just wrap that, and then that will work.
So ramp
Wrap. Yeah.
df.
Okay. Now this is a function that picks an x, which is the t, and returns a daf.
That's it. How much time did it take?
Let me check in on OBS. 8 minutes and 30 seconds.
I told you. I told you it's not gonna take
I
more.
think that's a
I would.
record, man.
Dude, I would feel like I had like I don't know brain damage if it took more than that. But anyway, okay, we can try to abstract on the same function. Because I think no, actually, I think those are the only two functions that are gonna be like this structure. The rest is kind of different. I think. Yeah. Okay. So let's think here. Uh, we can abstract a case. I'm pretty comfortable with that. But then that would imply making two new expressions. I don't know if we want that. Phone call. Or do we? I'm very tempted to just leave it like this, man.
Yeah, no, I'm thinking about that because my first intuition is, man, we should pick the function f and apply fmap on that on the second one, right?
Fmap on
Yeah,
that
because
on
we
the
have a
second
t
one.
inside the second dependency, and we have a function that picks the t and transforms that to a parser of u.
Mm-hmm.
But here we don't have anything to like join because it's gonna be the final type will be parser of a parser of u, and we need
Uh-huh.
to get rid of one of them. And
Let's make the annotation, by the way, on this. So what is f? F
HB.
takes a to b, which is a function. So let's use like F sharpisms again. I'm
Okay.
comfortable. I feel comfy. And the p, which is the parser, parser,
Yeah, which is a parser of t.
which is just a parser t.
And the return is parser of u.
That's it.
Yeah. Yeah, so I think, can you see now that the final, if we pick the parser of the bind and apply fmap, we're using the f, we're going to have a parser of u.
Mm-hmm.
And that sucks. Because
Yeah.
we need to get rid of one of them.
We need
So,
to do a lift somehow. I don't
yeah,
want to do that.
yeah, yeah, so let's leave it like this, I guess. Like, because,
We're giving up.
yeah.
Oh man. Yeah, we can optimize the code later.
Okay,
Let's
so
just
what's the
do.
next step then?
So the next step is now we need some mechanism to keep iterating over the parser, right? Because right now we have the two main functions, which is you map stuff and you know how to bind stuff. But you need to keep consuming some sort of input inside of it. So we need a function that is like a while that will basically take something like a character, a parser, sorry, that is a predicate. So we need to start small, like a character. So
How
it
the
takes a
paper
character.
manages this?
I think he takes as a character. I'm not looking now, by the way.
No, but
But
I
if I take a look, I think it's search for a while, something like this. But essentially, it's a function that will take a a
Oh,
character,
okay, it's the many.
and then
I
it's gonna
remember
spit
this guy.
I don't know, boolean, whatever. I think it's a boolean, and that's just a predicate that you're gonna search. And then from there, you basically spit the function, which is a string parser. So it's basically the matched string. Uh, there are some other ways, like it's the man, it's no functions like this in parser
Wait, I'm not
or
looking.
string. Like in the parser combinators, like you can make. I don't want to use a string because that's the name. That's just a type name, right?
Yeah,
But it's often like p string, something like this, and then it passes a abc and the input, whatever, and then it tries to match abc inside of his input. This input. There's another one, which is many, for example, many ones. So it tries to find many ABCs inside this, at least
yeah,
one.
yeah,
Otherwise, it fails. So that kind of thing.
yeah, yeah, yeah,
So
yeah. I
this is
remember
the
those.
smallest. So this is the smallest parser we need. So let's do a while. I think that will be clear. We could also ignore it, I think. Yeah, let's just do the signature at the very least, so we don't get
Yeah,
confused.
I'm kind of regretting because looking at this, the guy's using list comparison all the time and stuff like that. I kind of think that it's the applicative one is more elegant, but anyway,
What
let's
we
go.
need is a thing that takes a predicate. Oops. Oh man, what the heck? I'm mistyping everything. That takes a character and then it spits a boolean like that. So
Okay.
it's just a way to say, okay, so this character is part of the expression that I want.
Yeah.
So that's it. And then we keep iterating over this to make sure that all the characters that you passed, that you want to bind in that parser, represent the correct thing. And then the output of this thing will be a parser of a string. Something like this. Let's do the following. Let's make all the annotations first. I think that's more useful.
Yeah, that's a very Haskell way of doing things, but okay.
So let me skim over here. Where do I have it? Okay.
Holy man, this guy uses a lot of list comprehension all the time.
I hate list comprehension. disgusting. We need to make also the left and the choice operator. So like to get the left or the right.
What
To
exactly
get
is the choice operator?
it's this.
Oh, it is the pipe.
Oops, sorry. I don't know if it's pipe. It's this. Uh, I don't know if I can make a function like this. Probably I can. It's a function like that that will take. Let me just make a parser A, parser B, like two parsers, one to the left and one to the right, and then parser A is essentially a parser of T,
Okay.
and parser B is essentially a parser of U. So we're basically choosing the parser on the right, which is B in this case. So this one will spit parser, oops, parser B, which is oops, I'm stupid, which is parser U.
Yeah, this is exactly the same operator in Haskell.
But
Congrats.
he does need to consume the parser T correctly, right?
Yeah, that's
Yes.
actually something important. We need to
Yeah, the
consume the
first one,
first
which
one.
is like,
No, we not we consume, but we
there
ignore
is
the
this
result.
failure.
Oh, that's the consume, you know?
Yeah.
Yeah, this one it doesn't, which is okay. So try to parse, otherwise it fail. Otherwise it just fails and show me the stuff. And this one is the opposite, so it spits T
Yeah.
instead. We want the thing that will basically be P. So this one is weirder because it will basically just compose those two things in a tuple. So
Okay, I
it's
know the
gotta
type
be
signature of this one. Oh wait,
this.
you want to
The
use them?
order for this one matter, right?
The
Yeah,
order
the
matters.
order
The
The
order
matters.
first
matters.
one
The
will be
order
tried
matters.
first, and okay.
Yes. I
Um.
actually don't know what I mean by order. Like all this also matters the order.
But what I mean is a choice of parsing one of those parsers, right? When you are concatenating with the last operator.
Is a choice of. Say it again.
So, for instance, I have like a string and an int parser, and I will use this operator, and he will parse one of those, right? If one of those match, it will be
Oh
successful,
yeah.
right?
Yeah.
So the order in which I like use the things with the operators, they matter, right? Because the first one matches, then he doesn't try the others, right?
No. Yeah.
Yeah, they don't try the order. Uh. Okay, that's a very interesting interpretation of the applicative thing, Mageta. I never thought about like doing like that.
There is also this,
Yeah, this is the
which
alternative.
is yes.
Oh
This one
wait,
will essentially
I
take.
think it was this one that I was thinking about. What is? Wait, what the fuck?
No, it's because
This will,
the previous one
yeah,
theoretically
but
should be applicative, Nathan.
yeah, this one
Uh,
But
takes two
does
at
the
the same
same
time.
thing?
no, they are not the same. The alternative, they try both sides, and the first one that matches, it executes only one that matched. And the applicative, they are accumulating. They are accumulating. So you apply the first, pick the result of that, and go to the second.
Wait.
Oh,
What are you
then
guys
my
are talking about
description was
applicative?
wrong because I think I
What
was
are you guys are
describing
talking about
this.
applicative?
Wait, can you say again, Maget?
No, like say your description again, Nata. I'm confused.
My description is you pass a bunch of parsers, and the first one
Uh
that
huh.
matches, it returns the successful.
That's alternative.
Yeah, that's
So that's
alternative.
this one now that you just.
Yes. I'm
Oh,
sorry.
okay.
Yeah, this.
I didn't
Yeah,
understood it correctly then.
that's right.
Didn't understand it. Okay,
Okay,
so
there's this.
yeah, the alternative for me is the most elegant one in this entire thing. Uh,
Thanks, I guess. There is also
no, I'm
what?
talking about the about
Yeah.
using the parser combinator. When I'm using alternative, man, it's so elegant.
Okay.
Holy crap!
There is also how I think it was like
But
this.
I think it's also a weak spot, Lemus. in the sense that with other tools, the order doesn't matter, I guess.
No, but if the order matters, you shouldn't be using alternative.
No, no, that's what I mean. When you are like selecting between multiple things, like, oh, let's parse a type. Then I type could be either this or this. In the parse combinator case, you use like this operator, right?
Yeah.
And the order matters, and it is elegant. But in other tools, when you want to solve the same job, you don't have the like the bad thing of the order, like matter or not, right?
No, but if the order matters, you shouldn't be using alternative. That's what I'm saying.
Fair.
You should be using applicative for that. Uh, okay.
Okay, T
Yeah, we are basically
is
making the entire auto parsec
yeah,
library.
that's yeah. Parser is one
Oh
the
no.
list of T. Okay, so I think that's enough
Man,
for
I
now.
bet that if we show this code of using F sharp type signatures in a Lispy language, Commander would cry.
I think we need. Oh, this is wrong. We can't do this name nomenclature here. I think.
That sucks.
Yeah, we're gonna have to find another one or just type because you see it broke here. So, folks, I need to have dinner. Now, can we pause the
Let
recording? I
uh
take like 15 minutes or something.
Mageta, just one thing before
Or
you go.
okay, so the recording is still going now.
okay.
Okay, so which one should be the first one that we should do?
Uh, let me think here. What is the easiest one, and what is the most necessary so we can actually already start to something?
A question. Do we have one there that we don't need?
Uh,
No, we don't need anything yet. Actually, just
Huh?
yeah. I mean, we just need this.
no, man, I think we
Now,
need
one
all of
of
them.
these. No, no. Like one of these two you need because the rest you can just swap the order. So
That's
just for
terrible. We're gonna
convenience.
have to be flipping things around, man. We're gonna
Oh
get
yeah,
lost.
but just think of the essential, right? So just think of the essentials.
No, but I mean
Um,
something I would not use, even if I can compose with the most core ones, right?
this one is
Let's
useless.
make the while though.
I mean, it's useful, but yeah, kind of meh.
The author does not name the while as a while. It names set as satisfies a predicate.
Yeah, whatever, man. Scott's name's as well, so I'll go with Scott. Scott is the dude.
Yeah. So to do this one is
Continue,
pretty
man.
easy.
Whatever. Continue. Stuff like this.
Yeah, that's better. That's better actually.
It is?
So,
Yeah, because the boolean
continuous
will
parsing,
just
right?
yeah exactly the boolean will tell us if we
Oh,
can
wait.
Continue.
Yeah, continue parsing.
yeah.
We need another one, which is
Continue. Let me see.
prefix. We also don't need, but that would be cool to have,
No,
which
but wait. I
is
think that the status.
string.
I think that the meanings are different. The parse that he calls satisfies a predicate is not about reapplying like continue parsing. It's just to from a predicate generate a parser for me. That's basically what's happening here.
Oh, okay.
No, wait.
That's
So
different.
From what I remember is you give a predicate, and then from this predicate you generate a parser with the string that matches this occurs.
What?
well,
So, for
signature
example,
is as you said, Lemus. It's regenerating a parsing from a predicate.
yeah,
Wait.
It's
like
because you're
we're
not
thinking,
executing it yet, right?
yeah.
Well, I need to check what the result function that this guy. Oh, it's the
This would
wrapper. Okay,
be
the result is a wrapper.
yeah,
Okay. Um.
because we would need to something like you get the go over each position, like you need to iterate over the string, correct? Of the input, I mean. So you get the input, you go iterating over it, and then you go applying the parser, which is the predicate, because each element will now be the character. And if they comply with the rule, then you might know in the end because you have the length. And if they are right, then in the end you match. It means that it matched the parser, so you can make a new parser with a subtracted input that matched with the parser. Did you get it?
Yeah, I do, but that's not what the satisfy parser that this guy is talking about does. I guess.
Satisfy parser? What is the
Yeah,
satisfy
I'm
parser?
gonna
No,
copy.
the satisfy parser, that's a different one.
No, the type signature is basically the same, almost the same, almost.
Because no, there is also, I think satisfy may be this. Let's call this satisfy, which is, well, you send a match, which is a string, and then this thing returns, well, it just returns a parser of string. You match a string inside. That's a different thing than this.
Yeah, no, but that's what I'm saying. The satisfy that the author uses is you pick a function that he's calling a predicate that is a function that picks a char and returns a boolean, and the return type is a parser of a char. Okay, so
Parse.
that's
Okay. I see what it
yeah,
means.
yeah.
This is actually the same thing, but I'm picking like many already. But we can we have the many. So in this case, it could be this. Okay, and then we can use this thing. Let's actually. I think that's better. Let's do this.
Yeah,
Satisfy. So
yeah,
this is satisfy,
yeah,
and then we can use many. You see,
yeah,
and then with the many we have a list of chars, which is a string.
yeah. Pretty much.
So
I
I think
think
that's
that it's
better.
that one thing that we can do is to make all the basic parsers to kind of get the jam on how to do things. Because there's a bunch of basic ones like letter, lower upper digit.
Yeah, we can do whatever, man. We're not like bound to a. Well, it's a, definitely a finite set, but
Yeah.
we can choose to ditch some. Like that would depend.
Okay, so let's make
It would certainly make it
the
easier.
parser for a char, just for now. So that fun char, you're gonna receive a char C.
So match char.
Yeah. And in this inside it you're gonna call the satisfy one
Wait a second, and then we.
parser char. Yeah. Yeah. So
Okay.
let's make the satisfy first. So let's build basic units and then let's build more complicated units from those. So the satisfy is the following. You basically do the same structure as always. So make parser run blah blah blah, blah lambda input.
Blah blah lambda. That's how you say randoms.
Yeah, it's,
Blah blah
it's
lambda.
exactly the same as always, as we did in the bind and the other one.
Okay.
Okay, and then
Here's
we're gonna do the following. We're gonna pick the predicate and apply that to the input and check if the result is true. So it's basically an if, right?
yeah, but we gotta do it before. So do we have if?
I think so.
I hope we do.
No, I think so.
So we never know.
A fun call,
So,
predicate, input.
um, but we gotta take the thing out of the input. So we gotta take the position out of the
Yeah, no, the guy
out
is
of the
using
input.
bind for that here. He's applying
It's
bind.
using bind.
Yeah, because with the bind you can kind of unwrap the thing, right? He's using bind in this particular case.
Okay. Okay, I see why, but that still doesn't unpack the element. Like it doesn't take the char, right? That's the my point.
It does not take the
Because it's a
char.
string, so it's a list. Yeah, the input is a list. For to type it, it's a list char. It's not a char. You see?
Yeah, but it
So we
shouldn't be.
gotta take
It
like the
should be a
first
char.
position.
It should be a char.
No, the input is actually a record.
The input is
So
a
you need to
record.
unpack the rec. Yeah, the input is this. It is a thing that has text inside.
Yeah, I see. I see. The guy is using bind. How can we use bind in this particular case? Let me think a little.
No, the bind, dude. The bind will be you take this, which is the predicate, which is the function that will
Wait, wait,
spit
wait. Look at this type
a
signature. Do you
parser.
agree that if we use bind, the function, the type t in that f will be char?
Yes.
Yeah, so that's what we want.
And then u is a string. Yeah.
Yeah, so that's kind of what we want.
But we need to make a function that will take a char and will wrap in a string.
Oh, but we have that, don't we?
Do we? I don't think
Isn't
so.
the wrap? What wrap does again?
No, the wrap. No, wrap is just a dummy thing. It takes an input and wraps the value. But it would be still char. We don't
Oh,
want this char. We want a thing that takes a string and transforms it into a char. You see? Like, which is essentially, okay, just get the first one. So that's what I'm saying we
no, no,
should
no,
do.
but later on we can combine the many in this parser char to make the parser of a string. There's no problem. We are making the basic units now. So let's assume that the t is a char in this case, because later we're gonna combine that with the many, and then we're gonna have a parser of a string.
But the record will still be wrong, man.
Yeah, that's a
Which is
problem
the input.
actually.
So we either ignore completely that, or we just handle as something.
Oh, it's because our functions, the bind and the fmap, they are bound to the input, which is a text inside.
Yes.
Yeah, okay. So this is because we are doing monomorphic bindings in maps.
I mean, we could. Dude, I think that's. We're just concerned. I think we're too concerned with something. Because think about this, like. Do you agree? Where is the satisfy? Here. Do you agree that this function here, looking at this signature, it's basically telling me, okay, so get a predicate and then wrap it up. Let's say we want a string, okay? In the
We
end.
don't have the many, so that's hard.
Wait. The many is essentially just while. That's why I was calling while. Because what you need to do here to complete this type here is get start from the first position. Then if the predicate is in this thing, like if it matches, then I don't know, this is a table saying, okay, so if it's A, then okay. If it's B, then okay. But if you just pass one parameter, we're already just binding a char. You just happen to get one, but that's it.
No, but that's the point, Magenta. The whole point is to make very simple parsers that parse very, let's say,
But this is
useless
simple.
stuff. No, well, you can say that, but we don't have the many still, so.
You don't need the many, man. That's what I'm saying. You just make a iteration loop. That's it.
I'm not a fan of jumping steps, but we can go that way if you want.
I don't know how to make a loop here. I don't think we do have. I think we need to make recursion, which is kind of hellish.
Yeah, that's why I don't like this way. That's why I like the simple first.
No, we're gonna. Oh, man, we're gonna have to do that anyway. I think we can do. Yeah, we have flat, so that's less worse.
What is flat is
Let for functions. So we can make like. I hear the noises soon. So we can do something like loop. See, and then you make a function here.
Yeah. I don't
What
know.
about we do other dummy? Let's do other stupid
No, but this is
parsers first.
but this is the dummiest one, man. The satisfy one
No,
is the dummiest one of all of
this
them.
is the one. Match char. That's how I'm calling match char.
But the match
Which is
char
basically get a
uses the
char.
satisfy using the function equality. That you're done. You're done.
Makes
The
sense.
function
Makes sense,
equality, man.
right? Makes sense.
Yeah. I was
Dude, what do you
thinking
mean,
about
man?
that.
Exactly that. So let's
Like
suppose
you
that you
can
have a
write.
satisfy function, right? You have a you pass a predicate and it's gonna
No,
return
no,
you a
no, no.
parser of a char.
I think you're not getting what I'm calling satisfy and what you are calling satisfy. What is satisfy?
Satisfy is a function that picks a char. That picks a
Okay.
char. No, picks a predicate. Sorry, picks a predicate that picks a char
That
and
was my
returns a boolean,
prefix.
and then it returns you a parser applying that predicate to to some input. In this particular case, the input is a char. And then it's going to return you or a dummy parser or a parser containing the value that
I don't
satisfies the
think that's the
predicate.
easiest you can do, but that's
What
fine.
do you mean the dummy parser?
Yeah,
Wrap.
in the paper he has a parser called zero, which basically produces an empty list out of any input, right?
Oh, okay, but that's either parse or fails, right? He's using
Yes,
the
yes,
either empty list or singleton. Okay.
yes, exactly. So that's it. And in the char, it's easy because the predicate is equal.
Yeah.
Uh, no, but that's just a suggestion. I want to know what you Nathan and Magetta think.
Wait, you, Nathan, and Magetta?
Yeah,
What the fuck? Who is you?
yeah. You in English can be for multiple people, man.
Wait.
He's referring
Well,
to.
go on. I will think about that.
Yeah. So, for instance, Magetta apparently does not agree that the simplest one is the satisfy. So, which one is the simplest one?
No, okay. I don't see how you're saying this is simple. Like, say it again. What do you want to do?
Uh, okay. So, what I want to do?
Like, explain like algorithms. What do you want to do?
Let me try Lemus, and then you say if it's right or wrong.
Okay.
Uh, well, I think we have parsers, and the way I understood is that we can either fail or not in an input, right? The way that the guys representing that on the paper is either an empty list
Yeah.
or a list with something that was parsed correctly, right?
Yes.
And then we do the predicate on the input to see if it was successful or not. And that's the predicate.
Yeah.
And then you just check if it's fair or not, and then you just wrap it, and that's it.
Yeah. Pretty much.
Now, I think the thing that he's saying, and I think it doesn't matter, we could implement using that or could implement, I don't know, doesn't matter. You could do both separately. But what I think he's trying to say is we can use that, passing the predicate of is the char of the input equal to this other char. If you pass in this as the predicate, then it's the same thing as the match char.
Yeah. Exactly.
So
So
that's that. So that's more generic than just character, actually.
yeah, no, that is, but that's the
Yeah,
trick.
I was not thinking about that. I was thinking about parsing necessarily a string, so that's why I got confused.
Yeah, but that's the thing. We in Lisp we kind of don't have to like
No,
types
man,
per
ignore
se,
the least.
so
No,
we can
man, no.
explore this fact to make very generic parsers later. I agree with that.
But
But I want to make the char one first with the satisfy because just to get a taste of how to do it. Because after we have the first ones done, the next ones
okay.
will be natural, be very natural. Okay, so the first thing that we need to do actually is to change the wrap function. Can we go to the wrap function, please?
Wait. So just gotta change this part here, which is the predicate. So funcal instead of the parser, we just pass the predicate.
Yeah, here's the
Okay, what do
wrap,
you want to
right?
change here?
Oh man,
Uh,
this keyboard sounds really nice.
yeah, that's exactly what we
What?
want. Okay, that's the first part. In the paper, Nathan, he calls this result. You pick an A and you it returns a parser of that A, which is exactly what we're doing here with the wrap.
Wait,
Nice.
one that always is successful?
Yeah, in this case, we are wrapping
Yeah,
with
this
success.
is just kind of stupid.
Yeah,
Yeah.
we are wrapping with success.
Wait, let
We
me.
could also make a fail here.
That's the result, right? That you said?
That's the result, yes.
Fail.
Okay, I will take a look.
Yeah. Okay, that's actually the 0. I think that the fail one is the 0 for the guy. Awesome. Okay, now
It's called zero.
now we have everything that we need to make the satisfy. Okay, so let's go down a little bit to the satisfy. Okay, we're gonna make a new parser. That's
Just apply, just run, and then on the success case, you just return a tuple
wait,
with
wait, my man, wait.
wait what?
Okay, so I will give
Oh
you a
wait,
suggestion. Is that fine?
yeah, go.
Okay, so the okay, remove the make parser and the run, please. Because we're gonna use the wrapper at the end instead of
Why?
make. Because we're gonna use the wrapper at the end to make the parser. We're not gonna make the parser here.
But you need the input.
Yeah, the input. Oh wait, I need to translate this because the guy is using a bind in this case.
Lemus, man, I'm taking a look on the result and I'm not understanding why we need it because we're not really parsing, right? We're just
Wait,
adding something to the.
wait, not done. Wait just a sec. Maget, you are right. We can use this instead of. It's because I need to translate the implementation that the guy is using and bind to this. We can do it in your way. You pick the fun. The next is applying predicate to the input. Okay, so this is not next. Change the name of that. This is, I don't know, condition, whatever. And then if condition true,
Okay, because the predicate returns a bool.
yes. If the condition of this is true, we're gonna do wrap input. Done.
Okay, so if it is true, we're
Wrap
just gonna
input.
wrap
Input.
the input.
If
Okay.
it's not, 0.
Otherwise,
Okay, I think this is the exact
and
same thing that the guy is doing in the paper.
I think I'm passing here.
And that's it.
Okay.
Okay, now to do the char, let's test. Let's make the char parser, match char. You're gonna call satisfy, and inside that you're gonna make a lambda. Lambda input.
Lambda with the char.
Yes. Then
And then we need to pick the
no, but
first
you
element
need to
of
change the
the.
names. There are two chars here. Yes. Now the function is
How
char
do I take?
equals
No,
input
but dude,
equals input. That's it.
no, but wait. How do I take the input? How do I take a first element out of a string?
No, but this is not a string. Look at the.
Okay, you're considering the scope of this thing. Okay, but then here's the problem. Like this is not consistent anymore because the parser here needs to be. What is a parser? The parser
Is a record
is
that has text inside.
just a run.
Oh no, you're talking about the input, I guess, right?
Because this is. I mean, I think this is gonna break.
Wait, let's just see. Let's see.
No, but dude, because the parser, you need to spit a tuple of input, the success, and the value.
Yeah, that's
If it
fine.
has a value.
Yeah, that's fine.
We're not doing that.
Where are we not? We are not doing that. Where?
Let's see. Satisfy. Oh,
Yeah.
actually, the wrap already does that. With the input and the 0, you don't need to pass. Oh, wait. We need to pass the input to 0 as well, right?
No, we don't.
We don't, but then this input is just from the lambda.
Yeah, the input is just from the lambda. I think you're gonna
But
have a.
on the wrap, we totally ignore it.
Yeah. Yeah. On the wrap, we totally
Should
ignore
we?
it. Yeah, should we? We should.
We
We
should.
should. Yeah, that's exactly
Why?
what we want.
We're losing the old state then.
Because the wrapper is just something to wrap the type. We don't care about the input at all in this particular case. It's just to wrap
Okay,
the type.
this is your result, right?
Yes, this is the result.
Okay. Result 0.
Yeah.
And what is the item? Wait, is it item? Yeah, what's the item?
Item is another parser that he made that you check if you have an empty list or you
No,
have
no.
something.
I mean, where is it?
I
Like, do we
remember the
have it?
item.
No, we don't have it, but I don't think we need it.
No, we don't.
Oh, okay.
Okay, I have a problem in the satisfy function. Nageta, can we agree that the wrap input returns a parser? Can we
The
agree on that?
wrap input, yes, it does.
Yeah, so
Yes,
why
but
are we
we're losing
calling
the.
make parser run then? Why?
No, but wait, man. This is not the input. That's what I'm saying.
No, it's not the input that you're talking about the record, right? It's not that. Forget about that.
Yeah, on the zero it doesn't matter, but here it does. Oh, this is the value now. Okay, never mind.
Yeah, exactly. But do you agree that we are doing something wrong because make parser run, we are constructing a parser. What
Yes.
this lambda should return? This lambda should return a tuple, but we are not returning a tuple.
Yes.
Yes, that's exactly what we want. Okay, the satisfy input, and then you're gonna instead of if, you're just gonna do input equals char. That's it. We are so close.
Let me just open the Erlang modules here. Ah, man, that'll be hellish to fix later. I don't want to do this.
No, it's not if input, man. Just do input equals char. That's the function. Equality, I don't know how to do equality in Erlang or LFA.
Oh, we can do Erlang, but I don't want to do that. Ah, man, what the heck? Just want to do equal. Input and ch. That'll be hellish, but let's discover.
Okay, this should work. Let's test it. This should work fine.
So, how was the name? Match? Yes.
Yeah, but this will return you a parser. Remember that also, okay? We need to do a let.
Yes, I
this
know.
guy.
Okay, this is wrong because we returned a fun, not a parser.
Okay, so something is really wrong there. Oh, it's because the function needs to return an input to then to be evaluated to a parser. Okay.
But this is the... Dude, this is wrong because this depends on the parser. Okay, this returns a lambda that we evaluate inside another parser.
Yeah, this
No, that's
returns a
still
parser
wrong.
by itself.
No, it doesn't.
It should. Wrap
Like
input needs a
this
parser.
lambda returns a parser. That's what's wrong.
This lambda returns a parser.
Because this is a lambda. Like this is wrapping a lambda and there's a parser inside the lambda.
Oh, so maybe we do need to do the other way around. Make parser run, right?
Yeah, the other way.
I'm gonna have to change the
right.
wrap in the zero.
Make parser.
Oh, but that's
Just
easy.
add
Oh,
parser.
nice.
Oops, I think it's just this.
Yeah.
Run.
Yeah, add parentheses, but we need to change the wrap and the zero. These now need to be tuple. Let's go back.
The wrap and the zero.
They need to be tuple now. Yeah, they need to be tuples now.
Why?
Because what is a
already tuple.
parser? A parser is a run that picks in lambda and returns a tuple. This is a parser. Do you agree?
Oh, no, but they already return.
They return a parser. Wrap and zero, they return a full-blown parser by themselves, which is not what we want.
Yes. Why?
Because we already have a parser, because you're using make parser run.
Dude, I don't understand why you want to wrap it in a tuple.
No,
like
I don't want to wrap this in a
tuple?
tuple. I want to change the implementation of wrap and zero. Instead of them returning a parser, they return a tuple.
They already do that. Oh, no. Okay, I see what you mean. They return a lambda with a tuple.
Yeah, just the tuple. Should be just the tuple.
But dude, if you remove the lambda, if you remove the parser part of it...
Because
That's weird. That's not the wrapper
that's
zero
not-
anymore.
no, that's not the wrapper. They're not done. Those guys this proposal that I'm saying here, this is not following the paper anymore. But I don't think we have a choice, because if we do the way that the paper is saying we have that result function, but we don't want a function, we want a parser there. In Haskell, that works. But in here, instead of...
Wait, but a function, well, a parser is a function, right? So, not
Yeah, no, it
sure what
is,
you're.
but how do I explain this? Yeah, but the value is wrong that particular case.
Yeah, fuck the value.
Yeah, just put input
You.
there. Put input instead of... Yeah, put that. Yes. Yeah, let's test that.
That's
Let's
stupid to
let's
me, but.
test. Let's test. If it works, I'm happy. Try to do the same thing. Match char. What is this now? Nice. Okay,
Parser.
this is a parser now. Okay, this is a function.
That takes an input,
Okay,
and then
try
it's
to...
gonna try to apply the predicate. Blah, blah,
Yeah,
blah.
try to put I don't know, b, like string b. Undefined function equality. Okay, we don't know how to do we don't know how to do equality.
Parser run.
What I get worried is that it doesn't complain, man.
It doesn't complain?
Yeah, like it doesn't. I
You
don't
mean the
know. Like it
editor?
compiles. It compiles, man.
Of course it compiles. We don't
Oh!
have types, man. We don't. We are
Dude,
thinking that the input
this is
is a
not a matter
record.
of types. Dude,
Yeah, it
this is
is,
not a
man.
matter of types.
Of
It's
course
an
it is, man.
invalid symbol.
No, man. Do you know why it's not? Because
Dude, what
we
does
are
this?
thinking.
What does this mean? What does this mean then? That's the thing. It's
Oh, you're talking about
nothing.
the equal. I was saying
Yeah,
I was talking about something else.
But isn't
like
that
this
just a
doesn't
valid
exist.
identifier?
No, it doesn't exist. Undefined function. This is stupid. This is bullshit.
No, but put the arity also.
I don't think it's like that.
Let's see how you do equal. Okay, equality Erlang.
Dude, this is retarded, man. What the heck?
Oh no. Oh, it's two equals. It's two equals, not only one equal, man.
Okay.
Oh.
Okay, save that.
Wait,
Okay.
but does that work as expected for char or string?
I don't know. I just hope it is.
Symbol new is unbound. It worked. Okay, then it worked then.
Mm.
We have we return a parser that returns a new, apparently.
Yeah.
Okay, okay, so this works.
Wait, what
I
did you
think that's
change
gonna
it?
cause.
Oh, okay, yeah.
I just applied a
Yeah,
different
exactly.
predicate.
Okay, so we have a parser that knows how to parse A.
I don't like this though, but anyway.
No, we can, but now we can discuss how to make it better. Now that it works.
No man, the problem is like making this a parser. Like that's the this structure. I think
Okay, so
Make
how would you
not
do it
low.
then? That's the question.
I wouldn't. That's
No,
the
no, no.
thing.
You would have to parse chars in some manner. So
Yeah,
how
you
would you
grab
do
the
it?
part you handle them as a list normally, and then you grab the thing and then you do a exact same match, but inside a fold or something like this. You treat them as like a list,
But
not as
isn't
an individual.
no, but
That's what I
isn't
mean.
what you say the combination of the many and the match char?
Yes.
Yeah. So
Then it's really redundant, right?
Yeah,
which
it
one
Like
is
is.
on both
redundant?
sides. Well, if you are saying that you implement the match char in this way, then it's redundant for the many and for the satisfy, right?
No, no, but this is a kind of design decision because if we do the way that Magetta is saying, okay, it will work. It's probably going to be less lines of code. But I suggested to do this way
Wait,
because
less lines of code? We only have one.
I don't.
what?
I think it doesn't matter to be
No, no,
honest.
no.
Wait,
But I
I just
suggested
think
to
it's
make.
clear to read.
That's the thing. I think it's clear to read
Yeah,
when you
maybe,
have
man.
basic
Whatever,
units being
whatever, man.
combined.
Whatever.
No,
When we
but that's
start
just
discussing like this, we should just ignore it.
no, but that's just Okay.
No, man, let's not go there.
I don't
We
understand, but
always
okay.
do this. We always do this, and we always spend like hours discussing stuff that
No,
in the
man.
end I don't care.
I don't
So
understand, but
okay,
okay.
what is this? This is just the get the rights. Okay, do you want to do this now? What do you want to do now? I'm just
No,
doing this.
no, feel free. We can
No, but
continue doing.
which one do you suggest? Like follow the paper.
No, the paper suggests to do the basic ones like the digit, the upper, the lower.
Yeah, it's the same thing. Upper. What
Yeah,
was the upper?
the upper is to verify if it's capital letter.
Oh, okay.
And it's basically reutilizing the satisfy parser, but changing the predicates a bunch of times. So it's basically like the satisfy is basically a really powerful block that we can reuse a bunch of times, just changing the predicate.
I think we can skip most of them and just do as we need. Let's
Okay,
just do the
let's make
more
the string.
useful
Let's make the
ones.
word one. What do you think about that?
Yeah, word is better.
Okay,
So
so that
match
fun
word.
match word.
We already have it here, I think. No, we had just a many, but we didn't do it. Match word. The full word.
Oh wait, we
Word.
also would have to do there is an intermediary step which is to make the plus parser, which basically picks two parsers and combine them together.
Oh, yes, the combine. We forgot about that.
Yeah, we need to do that also because a string is basically a combination of letters. Uh,
Oh,
yeah, plus
That
also.
would be the list that we have here with the many. We can do that with the many.
Okay, so let's. Uh, okay, the type signature. No, it's not the same. It's not the same the many because the many
Yeah,
picks
this
a.
is,
Okay, go. No, the match word requires another parser called plus, which is basically picks a parser, picks another parser, and returns a parser that is a combination of both.
the full combine,
Parser 1,
and
parser
then
A,
it's gonna
parser B.
be should be a list of parsers, right?
That's the wait.
We
Yeah,
can do like
let's
parsers
make it variadic. Let's make variadic. That's gonna be fun.
or not. So we can make a new parser,
Yes.
run, oops,
Which picks
and then here
a string,
an
an
input.
input. Sorry, picks an
Yeah,
input.
and then we need to chain all of those parsers with the input, and then just spit the final result. Is that correct?
Uh, you need to pick the input, put that to all the parsers, and then concat them together. I have to leave for a little bit.
Wait, concat or propagate the value like a pipe? I was thinking of a pipe. Concat is different.
Okay, an emergency happened here, but I will tell you what we need to do. You're gonna pick the
Yeah, but
input
why concat?
because concat is how you combine. At least in the paper, saying it makes sense because it's a bunch of strings in this case. Because the
Yeah, but
parsers they
that's
have all the
only in
same
this
type.
case, right?
It's a parser A. Like, imagine a list of parsers A's, and then because they all have the same type, and the author is assuming it is a string,
Yeah,
he is
okay.
using concatenation in this case. It's in page 7, the plus one.
So you
Uh,
take all the results, you apply input to all these parsers,
and
so
then
the
fold them,
same input,
and then
because
you
that's the problem. Like you apply the same input or the consumed input from the previous parser. That's what I was thinking. Just chaining, right?
no, that's chaining. That's not exact. That's not what the combine should do. The combine should do, like, pick the first result, the second result, and the third and the fourth, and then just put them like literally string concatenation.
It's kind of meh. I kind of don't see the point of doing this then.
The point is that a string is a concatenation of chars.
Yeah, but think about this. You're gonna have to make a new parser that will ignore Because the point of a parser is like evaluate on this next position now that this is the thing that I want or not.
Yeah, well, we can skip the combine, but if you want, because again, this is what you're saying is a more advanced step in step, but we can go there if you want. I have to leave here because
No,
things
no,
are
no, dude.
exploding.
The point is okay.
I'll be back in a few moments.
I will ignore this for now, man. Oh man, what the heck? This. Let's just do this. I think this is easy. Make parser. I'm kind of worried that he said things are exploding here. Anata?
Hmm.
Oh, you're still there. I was
I'm
saying I'm
reading the
kind of
paper.
worried that he said things are exploding here.
Yeah, I was worried regarding being an emergency, but
I
then,
think
I,
it's
yeah,
fine.
it doesn't seem like, I don't know, like,
An
I don't know.
emergency. Let me see. What do we do here, Nathan?
Oh man, I'm still reading the paper.
I remember reading that paper like a while ago, but I don't remember some stuff that he's doing. Do you remember that presentation I did? It was based on that.
Which one?
I did a presentation on parser combinators, I think. It was
I
based on that dude.
don't remember the specific occasion, I guess.
Of course you don't.
Wow, my memory sucks, man.
We just run a run viz on the input.
Okay, I'm back.
Okay, so things are what was exploding.
Yeah, no, my parents requested IT help.
Oh, okay.
Uh, okay, so what was the decision? We're gonna jump steps. We're gonna go to the end with the complicated
Dude,
parsers.
because here's the thing, I only see the case of that combine, which is like concat, for because what I get problematic is you need for that to work, you need the parser that will parse the next position.
In
Uh,
order to that to work.
so for example, yeah, for example, like you have oh man, what the heck? I can't click properly. A, B, C. Okay, so let's suppose you want to combine them, and you have a parser for A, parser for B, and a parser from C. Okay,
Yeah.
you're gonna have to have a while that you will iterate over these positions because the way our parser right now is okay. Just get the input and try to parse, and then it's gonna say okay. So try to apply the parser A on there. So what will happen is that it's gonna success. Cool, nice. And then what happens if you try to parser B in the same thing? It's gonna be failure. What happens if you try to parser C? Failure. So it doesn't matter. Like it's stupid. You
No
need a
man, no
parser.
man, no man. That's not what we are doing. What we want, I'm going to describe what we want. We want to make a
Hmm.
parser for strings,
Yes.
but we only have parsers for chars.
Yes.
So what we're gonna do? We're gonna pick every single char,
That's what I'm
parse
saying.
them,
You should
and then concat
consume the
them.
positions. Dude, that's what I'm saying. The concat will fail. There's no point in making the concat.
Concat will fail.
Dude, look at the example I just said. You have A, B, C, and you have a parser for A. I'll make the labels here. I have a parser from a parser from B, and a parser for C. They are just char parsers, correct?
Yeah, so you don't have A B C. You have A char, B char, and C char. That's it. The
What
string
is
is the
the
final
input?
result.
What is the input?
The input is a char A, a char B, and a char C, exactly as we did in the
Uh,
terminal there.
But it can only have one input.
Yes, but then when we do the combination and the parser for the string that the paper calls a word, we're gonna have everything to concat them together. But like I said, we can go your way, no problem. I just think it's gonna be
No, but
harder, but that's no
no,
problem.
dude, I don't understand. Okay, when you join them, okay, I see the point of joining the results.
Yes.
But I don't see how you join the input to provide to VisCode.
Uh,
How do you join the input?
how you join the
You
input?
need to join the input correctly.
Oh, it's because it's recursive.
Like I'm thinking of the word parser. The
Yeah,
word parser
okay.
receives a word, right?
Yeah,
So you need to send a word for the thing. You don't, or you just, I don't know, you dismember the word into like chars. You can also do that. You explode the string. I mean,
it's because it's recursive. So that's how the why the concat works. It's because the word calls itself until it finishes. But
okay, that's okay. That's a different thing. Okay, that's what I was saying about iterating over the thing. Because if you're just naively applying the same input, then you're gonna end up with just one success and the rest failure.
no, I agree with that. I'm just because we were doing the combine first, and the combine does not involve any of that. And but yes, you're right. The word actually is recursive with itself. So yeah.
So let's do the word first. Let's just start by the word and then we go back there.
Oh man.
I was doing. Let me just finish this because I was doing the right.
Okay. Yeah. So
Uh,
parse the parser
so
with the
this
input. Yeah.
so
Yeah.
this is uh, try to see something that follows from other thing from another parser because oh no that okay because we have this as well, right? Which is like but that's a different thing.
That's totally
I think
different
that we
thing.
yeah, which is like get uh,
I don't
I think it's
remember. I
this
don't remember.
in F sharp. I think in F sharp is this, which is chain this thing from the left, but get the thing from the. So there should be an A and a B, but then I want if this order matter if his order matches, I want the A. I don't want the B.
Yeah,
So that's
that's
the thing.
totally a different thing.
That's a different one. Yeah, some mistake here. So the next we could. Oh, this one is simple, I think. Yeah, this one is simple. We just want to chain the parsers. So that will be we get
Yeah,
we
we
get
need.
a top.
Yeah, we
Oh, we
got the. You
need
match the tuple. We're gonna have to do that every single time, man.
success value,
Yeah.
and then here we
Fun
do
call. Fun call.
fun call. Oops, that's wrong. Fun call of
Parser.
the
Parser run. Parser
parser
B. New
run
input.
of the parser B. Oops, it's B over the new input.
Yeah, and the other case is basically a fail, and that's pretty much.
Yes, that's it.
Yeah. Something that I think is gonna be terrible is the full-blown applicative. It combines the results into a tuple. That thing can be nested, right? So you can have a tuple, and inside you have a tuple and a tuple and a tuple and a tuple. We're gonna have to pattern match that manually, like.
Wait, what the fuck are all those tuples? Isn't the purpose of using
Oh, I see.
monadic not having the tuples?
Yeah, that's what I'm saying.
No, wait. This is not fun call. This is not fun call, by the way.
Yeah, this is just the
Yeah, this
error
is.
with it's just a tuple.
Yeah, just return exactly the crap there.
On HP.
But the problem, Nathan, that it is a monadic parser per se, but we don't have the abstractions. Like we only have pattern matching, so. Oh no. But okay.
That's the challenge.
Yeah.
We never used macros properly, man. We could
But
try.
what do you mean? Like, you can just do the bind, right?
Yeah. Wait, let me check
Yeah.
something. I always get
Okay, those
confused.
two are gone. Okay, this one will suck.
Yeah, so to match the word, we do the following.
We need to get each character out of the word and make a parser for each letter and just combine, just make a new function that will get a bunch of like parsers and combine the results. And that's it. So let's make the dummy combine. I'll not call it combine, I'll call it concat because that does make sense.
Okay, concat is better.
Concat.
Yeah, but we can make that variadic. That would be cool.
Yeah. Concat. Parsers.
Yeah.
And then we just return.
Lambda.
Let me
Uh,
think here.
no, you need to make the same exact algorithm. Make parser run lambda input.
We don't need the lambda, do we?
I think we do, man.
No, because we just want the result.
No, we want a new parser that is a combination of all of them.
But well, the input we're not feeding to the parser.
Yeah, the input we're not feeding.
Yeah,
No,
we
we
just
are.
want to combine the results of the parsers.
Yeah, but we need to get the input to all of them at the same time, right? How are we going to get
The
the input?
That's what I'm saying. The input for all of them will be different.
It shouldn't be. It should be the same.
But then it will fail everything.
Oh man, no.
Dude, that's what I'm saying. There are two concerns here. There's like, what you want to input to match word is ABC, so, right? And then you want to make a parser for A, a parser for B, and a parser for C. That's the only thing you know. And then if you feed the same input for each parser, there is basically a parser for a char, then you're gonna fail all the rest of the parsers.
Yeah, but you are jumping steps because the concat parser, it assumes that all of them have the same type. So it's going to be like parser A, and the concatenation of their results is also a parser A. Because you are going straight up to the string, man. We are so far from the string. The string is going to be the input of match word. It's not going to be the input of concat.
Yes, that's exactly what I'm arguing.
Yeah, but do you agree that if we have a string as an input for match word, we can apply a parser to start extracting the chars from it and parsing them separately and then combining them already parsed? Do you agree with that?
Say it again.
Yes. Okay, so do you agree that if we pass the input ABC as a string to match word, we can start extracting the chars from the string, passing to
Yes.
a parsers of chars, and then we
Yes.
want the combination of all the results of the parsers of chars.
Yes, but that's not the concat parser. That's what I'm saying. The concat parser just gets the result out of many parsers and join. You're saying, oh no, you send the same input for all of them. That's wrong.
Oh man, I don't know how to explain it.
Lemos,
Dude,
when you mean the same input, you mean like in parallel or sequencing? Because if it's
Parallel.
sequencing, what?
Yeah, totally
But
parallel.
then it doesn't make sense, man.
They have the same type, so it makes
Dude,
sense.
dude, you said this. You said the thing
Lemos,
that I said was right, and then you said the other thing. I don't understand. Like, look at what I'll do the thing here. So you want to dismember this, right? You want to do this,
Yeah, this is
and
what
this.
the word in the paper does.
Okay, you want to do this, and then you need to make a parser with an input for this, a parser for an input with this, and a parser with an input for this. And then the combine, you just send the application of all of these parsers, and then you join them.
it makes
What the way
sense.
you were saying was like, okay, you parse this to each one
No,
of
no,
them.
I didn't. I said that explicitly different. I said the input of concat would never be ABC. I said that. The input for concat will never be
Then
ABC.
it's not the same input. That's what I'm
Yeah, it
saying.
is. The input is always char.
Wait,
Oh, you're talking
wait.
about the type then. That's different.
Yeah, no, but that's what matters
I
for
wasn't talking about the type. No, man, but that's the thing. Okay, it's the same input in time in terms of types, but it's not the same input. It's not ABC
Yeah, no, the
or it's not
ABC is only the input.
AAA.
The ABC is going to be the input of match word. That's it. The concat is a mini parser that will work inside the match word. That's it.
Oh, you mean you will receive a list of parsers A? Is that what you mean by the same
Yeah.
input, like the same
Yes,
types?
yes.
Oh man, that's a really
You
weird
could have
way to
said it in a
say
better
it,
way,
man.
man. You could
They
have
are
said
they
it
are
in a
all
better way.
shards. They are 24
No, no,
shards.
but we didn't know you were talking about types.
But I said the
Yeah.
type is
No,
parser A that combines into a parser A. I said that multiple times.
But then you
uh,
do a, then it will not return a character, right? It will be like a list with one character, right? The result of parsing. If you want to have
Uh,
the same quote unquote type in the input and result. What I mean is list of parsers A to a parser A.
yes.
Then they need to return a list, right?
do we have an explode
Then
thing
can't you
on
do
our?
that with the map? Like it parses the thing and then maps to a singleton of a list?
I think you can use the map for that. But anyway, I think that because Magetta did this in the past, let's just follow Magetta's way. I think we're gonna jump a bunch of pages here, but that's fine.
No, no, that's fine, man. There is.
It's totally fine.
I'm looking at. Oh, there we can use the split. Okay, there is this on Erlang, which is a string. Wait, he? What the fuck? That's wrong, man. Oh, it's from regex, I think. Isn't there? I'm looking at the implementation. Is there no string split?
I think we do have that, man. 1 second.
We don't. What the?
Wait, wait.
That's. Oh man, that's really cursed. Okay, there is a module which I think is for regex, but it works.
String.
Yeah,
Okay,
this
so
one is for
string.
regex.
We do. Do we
That's
have
not good.
slice? We have split also. Nice. So it's string.
Yeah. This.
Yeah, string column split.
Okay, that works. Oh no! Look at the. What? Actually, that's not bad, right?
Wait, but what are you guys taking a look at? Oh, okay, there.
Yeah, like it splits, but this is regex. Do we have strings? I think it's just string, right? Nope.
Oh no, the split
ABC.
you need to pass the separator, I guess.
Yeah, but what if the separator is nothing? Motherfucker.
Strip. There's also strip.
Strip is different, I think. What? Oh, split is different. Split just splits at a position.
Yeah,
Oh man,
the
that's
first
stupid.
position. Oh, there's also trim.
Tring is for like removing stuff, right?
Oh yeah. Okay, so we don't have a function that returns chars. There's a function called chars.
String chars. That's a cursed name for a function.
I have to agree. But I don't think that's the one. I also don't think that's the one.
Wait, what do you want, Nemos?
I think we want a
Won't you
function that
explode
picks a
the
string
string?
and returns a list of chars.
Oh,
Uh,
yeah.
oh, it's CHR.
CHR. Oh,
Yeah,
here.
looking here, there's a CHR.
Returns an index of the first occurrence of the character.
No. Nope.
Yeah, that's not what we want.
There's a chars 3 and a chars 2. What does a chars 2 do?
Chars what?
There's a chars 2 and a chars 3.
Oh, yeah, they do the same thing, but they have different. Yeah, they are overloaded and crap. But they don't do what we
Oh,
want
there's.
also.
Dude, this is just a simple thing, man. To list, like.
I'm pretty sure we have.
Take title case to float tokens. Oh no, no, that's not what we want. Yeah, I don't think we do.
Words.
I don't think we have this, man. I'm
There is no
sorry.
way,
I'm
man.
sorry.
Can we do lists for each? I think it's just for. Let me see here. Oh,
What?
we can map.
Yeah, no, but what do you want to do, Mageta?
I just want to see if it iterates as a normal list or char shit. Potato. Yeah, okay, so it does. So we can use the lists function on a string.
Isn't that kind of like cheating or stuff like that?
No, why would that be cheating?
What do you mean?
Yeah, because well, I don't
It's
know.
not cheating, man.
I don't
It's not
know.
cheating. Doesn't matter what you say. You're just
If the thing is not complaining, right?
Oh, but wait, then we don't need combine. We can just do a fold.
Uh, yeah, no, my initial intention was to do a fold with concat as the function.
We want a map and fold, right?
You want?
Yeah, because we want to map to each parser and then fold the results of the parsers.
Yeah, yeah, that's what we want.
So we have a map fold here for lists.
We
Man,
do?
take a
Yes, we
look.
do.
No, take a look here, Lemos,
What? Sorry.
on the chat. The thing is
Uh,
like Haskell, man. That's already a list.
oh, so a string is a list of chars.
Yeah?
That's why I could run the
We
map.
also have list comprehension.
Oh no! Please
Holy!
don't put fire on that. No Pythonism, please.
No, what are you talking about?
Okay. Pythonism. That's Pythonism.
No, list comprehension came before that, man.
No, that's
No,
Pythonism.
that's
It's
not what he said.
appropriated. It has been appropriated. Doesn't matter when it came from.
Oh man,
Uh,
this would be so easy then because you can just basically copy paste the paper. But okay.
so let me think here. Let me see the parameters. So we receive the A, which is the state, I assume. Yes. No. It's the element and the accumulator, which is another thing.
Oh, map folder here. Okay.
And then we return a tuple with the thing and the accumulator. With
Yeah.
the new what is the B, man? Okay, it's the mapped state. Makes sense.
Yeah.
But wait, that's
Okay, this is a very convoluted way of doing a fold map.
but I think a map folder.
I
Dude,
mean,
I don't think this is doing what a map fold because you would map and then you would fold the result. But he's not doing that. Like this map fold shit is doing
oh,
a
he's doing a
map
fold and
and
then
a
a.
fold simultaneously. Like that's why would you do that?
Wait, what do you mean?
Look at this
Let me
example.
show this
No,
thing.
this is awesome. This is hilarious.
Okay,
Man,
send
look.
example.
Okay, I'm gonna send the example on the
Here.
chat.
I have here.
No, but
This is
that's
here.
bad.
Okay.
That's not impressive. That's the way
Okay,
I
I
want
have
it.
one example.
I want Nathan. Look at this. Tell me what you understand of this.
Map fold by the name or by the code?
By the
Like,
code. I just sent the code. Yeah, it's exactly
okay,
what Magette is showing
I
on the
have a
screen.
function that I have the current element and the accumulator. That's not the current element.
Why, man?
Hmm.
No man,
Why
wait.
would
What when I say to you fold map, what do you understand, Nathan?
Fold map, in this case,
map
map fold.
fold? Whatever. Yeah,
Yeah,
map
Okay,
fold. Yeah.
whatever.
so you map each element and then you just send to a normal fold.
Exactly. But
Yes.
look.
Look at what it's doing. Look here. So we get an
Look
X,
what.
we get the accumulator, and
Okay,
then
this
we return
X
a
is already
tuple.
mapped, right?
Yeah, no. This is mapping, this is folding.
Mm, wait,
So
can you
the
explain
result
me?
is
Yeah. So you're
one
gonna.
is mapping, one is folding.
Oh
And that's it. You return a tuple. You're not mapping and then folding. You're doing both at the same time.
Why would
That's
anybody
stupid.
do this, man? Why? Why? Okay, Nathan, look at the list. The list at the end of this line. Do you see that this is the input, right? Do you agree with that?
Yeah.
If you do a fold on this list,
Oh
starting from zero,
no! Holy fuck, man.
This is the result.
Why?
I don't know, man.
I'm
I don't
crying,
know.
man.
Dude,
Oh, man.
this smells like
What the
convenience.
fuck?
This is not like convenience. Somebody was doing some
No,
code and they
no, we
didn't
can
need
say
to.
that performance, right? But even though that's so
Yeah,
weird,
man.
man.
That's a bullshit reason, man. That's a bullshit reason.
What the fuck, man? That's
Man,
so bad.
that's unexpected to say the
Yeah,
least.
yeah, I would never expect that, man.
Okay, so we are gonna have
Holy.
to map and then fold. It's
We're gonna have to
corrected.
map and then fold because we don't have fold map. It took me a while to notice, but Baguette
Yeah,
noticed
but I was
first.
like, I was trying to run. I was trying to, and I was like, man, what the fuck? This is kind of weird.
There's no
What a
way
weird
this goes to
notation. What they're
15, man.
doing.
There's no way.
What the weird notation, man. What they're doing.
Oh man, that's I like. This was great.
And then we just pass X, and that's it. Yeah, that's it.
Oh
And
wait,
then hmm,
because the description of
what?
fold R says combines the operations of map and fold R into one pass.
Hold R.
Yeah, map fold R
Oh, okay.
combines the operations of map and fold R into one
Why?
pass.
Well, but it's like a simultaneous pass, right? Not a sequential one. But he's right. He's only iterating once through the list.
Ah man, this was great. took everybody a while to understand what
And
was
then, like,
going
that's
on.
something that, okay, if you want to do a function, like, you don't need to. That's confusing. Anyway, we should get. Where's the
Yeah,
fold here? I don't see the fold, man. Oh,
I
please.
think we have
Oh, here,
fold
fold.
L or fold R or something.
Yeah, fold L.
Yeah.
Okay, so let's read the annotation of fold L. So we get an element, which is the head of the thing, of the list, and then we accumulate and we return just the new accumulator, and
Yeah,
that's
it's
it.
it's a normal fold this.
Yeah, I hope. So let's pass.
Yeah, but there's
Remove
a
that.
problem because we have to fold parsers, man.
Yes. So how do we fold a parser? That's the problem.
We create
Well,
a new
isn't
one.
using like,
Parser.
We create a new one.
but
We
isn't just
create a
using
new
the
one.
combinators, man, that you already have, like bind and such?
Uh, uh,
Mm, no, the bind is different because it takes a thing and then it lifts to a parser. That's
yeah,
the
yeah, yeah,
difference.
yeah. No, the combinators will not
Oh
help
wait,
for
the
this, I guess.
combinator we had it annotated here. It was this, right? But then it would be all. Yeah, no, never mind. This is a different thing. So. Oh, but wait.
Wait.
Nathan is kind of right,
No,
man,
wait,
because
but the
we want to
parser,
get the
it is
things
a.
inside.
The
Wait, go to
parser.
the bind again.
No, yeah, because think about this, like, it could be a function that takes the thing inside the parser, right? And you receive a parser, so like, we just need to compose to gather all the characters. So we receive a list of characters, let's say, and then we lift to a parser. That's it. So we just want to uh, decompose all the parsers and then create a new one. That's it.
And
So
also
I was
combine
thinking of
their
using the
outputs.
bind. Yeah, I was thinking of using the bind, but I think it's better just to match. Oh, it's kind of easy, right? So you're just matching each one of them individually, and then you just get the result inside of that thing. But that's destroying the type parser.
No, we need a way to we need some some mechanism to combine two parsers. Let's start with something small.
Okay,
Two parsers.
combining which way? Can you show me?
Like
It's
this.
exactly the way that I'm trying to convince Mageta, Nathan. Is exactly the way that the page 7 on the paper is the
Wait,
same.
but Magget is showing the example. Like the example would help a lot on the actual
Uh,
input and output of the thing.
so you want to combine A and B, right?
Okay.
So you want to convert it some way to just A, B, and then you want to convert to
Wait,
parser.
what are those AB? Is it that the input of a char or is that a type of?
No, no, no. This is I'm not using this in purpose because
Oh,
this is like
okay.
the thing inside. So something like this, you see? You need to just extract the things inside and just compose them. So it's just a function. Oops. So it's just a function
Okay.
f that takes well, it could be something like this, right? List of char that leads into um oh, just a string,
But
and then
folks,
mhm.
that's just doing a sequence of a char that matches char and then maps on a singleton, right? And then you wrap the result of all of them in a concat.
Yes. Yeah, this is just like apply a function and wrap the result.
So if we do that operation for the two, then we just do the fucking fold, right?
Yeah.
Man, the thing that I think it's the most cool thing is to accumulate functions, man. Like you can do so much weird stuff with it.
Or not. It can come and bite you.
Well, sure, but
Like
it's,
Letris.
I was thinking regarding memory wise, it is pretty cool.
Let me think here. So how do we well, we need to unwrap that part
Oh.
and accumulate that in the thing, and then in the end we can just wrap. So let's just do the wrap. Uh, okay, but this is quite okay. We just what we do then. Oh man, because this is like an applicative in some sense, but with a combination, like a reduce.
Yeah, but the applicative is. It depends on how you see it, but I understand why
Yeah,
it's
because think
unnatural
about
to
this:
you.
if there it's a result type. So if there is something inside that is a failure, then you need to stop.
Mageta. Like, what about thinking about this naive way? Like, this naive way of receiving, let me see, two parses, right? And then
Mhm.
returning a parser that is a combination of both. So you receive two
Okay,
parsers and you receive the
yeah,
input.
makes
You run
sense.
the first, you check the thing, right? Like,
Hmm.
really naive.
Yeah, that's fine. So you're saying like here, right?
No, no,
We
like,
have the parser, and what is the accumulated parser, correct?
wait, but why don't we write the function that combine only the both like up there? That is much simpler, and we will need anyway, right, for other stuff, I guess.
Let's do it here. Oh, that's the concat. So
Can I try to describe the thing to see if I'm
yeah, I
getting
think I
it
got
right,
you. So parser,
and then you guys
yeah,
correct me if I'm wrong?
Wait, I need to explain something first that I think it's important because I think this is the like the source of confusion when we were talking about concatenating chars and getting strings out of that, and that's kind of convoluted and crap like that. The type the type signature. Let's just talk about the type. The type of the parser that the guy of the paper use, it's totally different than the type that we modeled, Mageta, because the guy picks an input and returns a list of tuples. We always return a tuple.
yeah.
So we don't have a concatenation like naturally. The guy has that because he's using a list.
I think that
But we don't need to. We don't
yeah.
need to for this case.
No, we
Uh,
do need to because
no, no,
no,
because
I
the
think
thing that he's using the list for is instead of a maybe, the list that we want is for
no,
the
it's not only
result
for
of
the
the
maybe. It's
parser,
not only
right?
for the maybe, Nathan. The parser, like I took while you guys were discussing, I took some time to read like kind of more like properly what's going on, and this concatenation of the plus parser that he's doing, where he picks a parser, another parser, and returns a new parser with this combination of them. The concat works for any type because everything is wrapped in a list. So this
Okay.
always work because it doesn't matter if it's a char, if it's a string, it doesn't matter because everything at the end of the day will be inside a list, and you can always concatenate two lists. So I think that the lesson learned here is if you don't want to use the list approach of like always instead of returning a tuple, we return a list of tuples. If you don't want to return a list, we're gonna have to be very creative with this thing. Uh,
Wait, the concat that you are saying is two lists or multiple lists to one list, right?
yes.
Yeah, but what he's doing doesn't do the string for us because he's also concating like the tuples and not the chars.
Okay, I will send to you no, not the parts of the code that I'm talking about. Okay, so this
Uh,
is the plus. Okay, so this is the plus that he's suggesting. And then
okay,
in the
so
parser of strings, he's using that guy. If you take a look on, oh crap, this is totally not formatted anymore. Uh,
I have two parsers here. What the fuck? Are you using the same input
yeah, because it doesn't
simultaneously?
matter because all
That's
of them will return a list. It doesn't matter.
but
Oh
I don't think that's what we want. We want to consume it like the chars one by one and then concat the
no,
result.
the word does that. The word parser does what you said.
Wait, isn't that what we want?
The plus serves a greater purpose of uniting different
Oh,
parsers of different
okay, the
natures.
more generic one.
Look at this. You want a letter to be upper. You want a letter to be categorized as a lower and upper. You do this.
End upper?
Yeah, a letter can be both of them.
Don't you mean or?
Uh, okay, let me give you an example then. Suppose that you want to parse this. Okay,
Okay,
one of them, if you try to use the lower, the return is going to be an empty list. But if you try
okay,
to use the upper, the return will be a and empty. It would be like this. What's the
okay.
concatenation of these two?
Wait. No, you are wrong. It's a tuple, right?
No, wait. I forgot the parentheses. Ironically, this. Okay. Now it's okay.
Okay.
Okay. Do you agree that the concatenation of the failure and the concatenation of the success will be only the
Okay.
success?
Now, what if both succeed? Like the lower upper doesn't work for this, but let's try something else. Something that both succeed.
Okay, just me finish. So this is gonna be like this. The other case that the guy has, I think they need to be or exclusive, Nathan. Because
Hmm.
the other example that the guy has is alphanumeric. Look at the alphanumeric now. Look at this.
Okay, I see.
So, but like I said, this is just an interpretation that I had reading this a little bit more
Okay, that,
slowly.
that that's quite interesting, man.
Yeah, but that's the thing. We don't have the abstraction of the list, which means that we need to be creative. So let's go back to the code and try to help Magit.
Yeah, but like that's the thing. Like we don't need
Yeah,
lists,
we
man.
don't need Lemos. We don't need like especially for this case where there are only two. We can literally just wrap them and oh no, wait, what the? We can just
What?
return either one or the other, right?
I don't know what you did, man, Magit.
So I was thinking of what to do to join. So what do you think of unwrapping? But then we need to propagate also this input, right? Which is the previous one. So we need to make a function that receives a tuple of value plus input or something like this because we need to join the input plus the value. Is that right?
need to join the input plus the value.
Yeah, the value is what is matching, and the input is the well, it's the string that you feed it into it. So like ABC would be like A to one, B to the other, and so on.
Yeah, but why the name of this is fmap?
Oh, I was thinking of doing an F map. Forget about it.
Oh, okay.
I don't
So
know what.
okay, so the parser is a tuple in this
Um,
case. So this is a result of something parsed, right?
Yeah, but I'm thinking. I don't think it's a good abstraction actually, because I don't want to. Because well, let me just express the way it would be. Let's do the following, man. Instead of doing this, let's do the dummy way, and then we think about that. So it was this, but then here we need to match the other thing as well. So that would be another case.
Okay. Something important. What you mean by join is picking the output of the first parser and putting that as the input of the second. Is that what you mean by join?
Taking the input of the first and
No,
giving
taking
as
the
the input of the
output.
second.
No, taking the output of the first and passing
No,
that
that's
as
not
the
what I meant.
input of the second.
What I meant is the concat. Like literally joining.
That
Like
part is
taking one thing.
confusing, Mageta, because say you just said the following. What I mean is the concat, but then at least for me, what the
I'm not
fuck is
saying
the
because
concat, right?
what he's describing to me is a chain, which is different.
Yeah, but can you write the annotations of this? Because
Okay, wait. Okay, let's do the annotations also. But Margareta, think about this. Do you agree that parser A and parser B can have any sort of type?
Yeah.
Yeah. So okay, but how do you gonna concat two parsers there? They can't be concatenated together. So
Well,
imagine a parser of a digit and
you
a
don't
parser of
check
a
that.
letter.
They're all strings in the end, actually. But yeah, I get what you mean. But like, we don't have to check that here.
We don't have to check that here.
Well, just don't misuse it. That's what I say.
oh man, fucking ties.
It's because the guy in the paper can do that because everything ends it with a list. You
Oh,
see?
here we can also lift everything to a tuple with a string
Okay, so
inside.
joining means making a tuple.
Yes, it could be making. Dude, it could make it a string. Like join is literally taking everything and wrapping into the same structure. In the same structure, could be could be anything. Could be a list. Could be a tuple. Could be a string. Doesn't matter.
Okay. Well, let's continue with the types here.
So here, it would be the
Okay.
result is. Oh, let's just do. So parser of A is a parser. Let's just limit them, okay? So this is a parser for a char. Could be other things, but like they need to be compatible, right? But it doesn't matter. We can also always
Let's
lift
go to
anything
this
to a.
specific case.
We can
String.
always lift to a string anyway.
Okay, that's the
So
string.
the what I'm saying is joining this and this. So we match parser A, get the input and the value A. If it's success, then we
But
match the parser B.
Mageta,
Mm,
but doesn't that restrain more combinations? Because since the result is a string, then I cannot like use the result to use that in a join with other parser char, right?
I didn't understand. Say it again, man.
Okay, you have operator. Let's call
Mhm.
operator because you have like two as input there, and they both are a parser of a char, and the result is a parser of a string. But if I want to use the operator on those two and use the result in the same operator with a new input, with a new parser, I can't because they. Uh, what I mean is,
Result.
take a look
Mm,
on the chat.
okay.
So you see that, right?
Yeah.
And it is parsed with the parentheses like this. Why does the result of the parentheses is still valid to do operation with for? Because the type of the output of the parentheses was the same type as the input. of the plus, right? So what I mean is, if you do your join, right, and I'm writing here the code for parser A and parser B, right? Oops. Join. I could not use the result of this parser
I
C.
still
That
there's
would
some.
be invalid, right?
Let me see a.
Because
So
the
the A,
result of
yeah,
join,
but
the inner one, would be string, right?
no, but wait. What I'm talking about join is something like this. That's what I think is different. Like it would be you
Line.
have this string. Let's add the parentheses.
Okay, I think I know how to
So
implement
the
this.
join that we want to do here is for a word, right? So for each word, it's not the expression, but you're saying I wasn't
Oh.
focusing that on making that generic because in that case you would have to have a parser for this, a parser for one, a
Wait,
parser
wait, wait.
for
I'm
us.
totally not getting it because the expression that I did there was not an input of a parser, whereas an example of an operation in
Mm.
which the output is the same as the inputs. And what that allows us is to keep applying it to the same operator, right?
But what I say is that, dude, I still didn't get because I'm just thinking of sequentially applying this thing and just joining, just dumbly joining the result.
What Nathan is talking about, Maget, is because if you pick the inner join, parser A and parser B, these may
Yeah.
result into a type that is different from parser C, and then the outer join will not work.
Yeah, that's it.
But that's not a problem because I think that the parser from the paper is already counting on that. We're gonna handle
No,
that
but
later. But I know how to do the
no,
join. Let's focus on how to do
no,
the
but
join because it's
okay,
fresh
but
in my
here,
mind.
you're saying okay, the type of the thing will be a string, not a char, right?
Yes, and the C is still a char.
Yeah, but a char here is also a string.
In this particular case, it's cheating, but it will work. But anyway,
No, but here's what I'm saying because it's an accumulator. That's the thing inside.
okay, but
This the parser A
let me
join with the
let
parser A
me
and
tell
parser
you
B
how
is
to do the join
accumulator.
because I will forget. So you're going to do the following: parser A and parser B, they are not tuples, they are parsers, which means that you need to run them. So what you're going to be doing is make parser, run, make a lambda, get the input, do a run with the A, do a case, do the same with the B, and concat them in the final tuple. I will say again. Uh, the final result of join should be a parser.
Oh yes, you're right because this has a phone inside. I forgot
Yes.
about that.
So we're gonna start with make parser run, exactly as we did with fmap and bind.
Yeah, but okay.
And then okay,
And
then we're gonna do a lambda, picking the input
yeah,
and doing a run with the A and the B. And
both at the same time, and then if
and
it's
and then you
both
do a case
success,
exactly, exactly.
okay.
You already got
Mhm.
it.
Yeah, I skipped this part. Copy this. So good not to have types.
Oh, yeah.
Let's see if I can. Be...
Imagine coding in a language that has types. It seems cringe to me.
Okay, Nathan. The answer to your question is the following. In the case of LFA, we are interpreting everything as a string, so everything is concatenable, let's say.
Yeah, then the signature is wrong, right? The
And
initial signature.
the
Yes.
implementation of the guy in the paper is also always concatenable because he's using a list. So I totally get what you meant, but I think that we are fine.
Yeah, that's not only the case for him because it doesn't matter only if It's a list, but the tuple inside of all the elements of the list needs to be of the same type. So he still has some,
Yeah, but it's always going to be a string, I guess.
yeah. But then it's not the list that is solving the problem.
Oh yeah, okay, that's actually true.
Like, okay, then he can concatenate, but doesn't solve the signature problem, right?
Okay, yeah, but just
Dude,
to help Mageta, now you do a case with next A.
I think okay, I see the problem because I would complain about this because what I was saying about the problem that okay when you end up here you're sending the same input which could be I don't know ABC to something that was supposed to just parse B, and then that's gonna result in a failure. Uh, but then in this case we're concerned with parsing. Um, no man, that's still wrong.
Wait.
Like, I'm thinking about something, but it's not the general case that Lemos is describing. Like, it's the case for we have a parser for a char and we have a string, and we can
Mm,
transform those.
dude, this is still wrong, man.
No, it's not
Because
wrong. It's not wrong. Let's just try. If it's wrong later, we can
give me
discuss.
give me an example. What is input here?
Uh, what is input?
Yeah, think about
The
this.
char
You have a
C.
parser.
The char C. That's the input.
Okay, the char C. And what is
Yeah,
the input here? The char C
char C, which means the
for
next A and next
parser.
B will be fail, right?
So you're joining a parser that is correct with main match. I don't know. This is parser. The parser. The A here killed the thing. But think about this. Oh, I don't know, man. Input is Z. Okay, input is Z. Anyway, the input is Z, and this parser is parser for A, and
Yeah,
then this parser is parser for B,
yeah,
and then you're trying to match both, and both will fail.
yeah.
That's
So
fine.
yeah, that's
But
fine.
now
Both will
think
fail.
of input as B. So this parser will fail. This
Yes.
one will work. And you're joining a parser that is failing with a parser that is working.
No, wait. But that's the thing, Magita. This is a difference in semantics. When a parser fails in the paper, you return an empty list, not a fail, not an exception. Here, our implementation, if you fail, the
Oh,
entire thing
okay. But
fails.
okay, I get it. Okay, I get it. But the thing is, that's why I'm saying you cannot do something like this, which is you send the same input for something and join them. We can't do this.
No,
Wait, is this join the plus that you were talking about, Lemos?
yes,
I think so.
yes, it is.
Then you said that it was not a problem for both to fail, but it is, right?
No, it's not because in his implementation, as far as I understood, if you fail, you just return an empty list, man.
Oh, okay. It's just a problem for both to succeed, right?
Uh, if it's a problem of both to succeed, yes, I guess. Yes, I guess.
Not really, right? If well, both can succeed, and that's not a problem.
No, but in the case of the
Like
the the, the
letter and digit, you cannot concat those, right?
yeah, you cannot concat those.
Okay, handling with types, you mean?
Yes, exactly. But that's the thing, Nathan. I agree with you, but in our case, our semantics is totally different because when you
No, no, but
fail,
it doesn't. Can't we just check? Like Magetta can just like do the okay. If both are wrong, then the result is wrong. If one of those is wrong, then the other is the result, right?
Dude, what I'm saying here is this input needs to be a word like this. Ignore this join, okay? This needs to be just a folding step out of something that receives a list of inputs. Two in this
Of
case.
inputs.
Yeah, this one receives two because you need to pass different inputs for this and a different input for this. Otherwise, it's always gonna fail.
Wait, but did you saw the one that he did an example on the chat, the plus one?
Uh, don't. I wasn't looking here. Let me see.
Because if
Plus
that's the one that he's talking about,
parser A, and parser A. It is, but that's the thing. The difference is the thing is different here because you cannot send the same thing, man. That's the problem.
Yeah, that's a difference in semantics. Like we modeled, like I should have thought about
uh,
this before.
Lemus, but
Yeah,
that's
this
what
is
I
not
just
a
said.
major
Like,
problem. We're
even
just
if you have
trying
a
to
result,
implement something different.
Lemus, we can do the result be the same as the list in this case. Because if both fail, then
We
it's a
just split.
failed, right?
Dude,
And
we're
if
just trying to do this condition here. We don't need to worry about sending the same thing and running the parser with the same input. We can just send different ones.
Go on, Nathan.
uh, but yeah, what I mean, I'm not sure if it applies to the fold or anything else. I'm only saying in regard to the plus function that you were talking about, right? Not
Yeah.
sure how you want to use it. But if you have the result type, you can use just the same as the list. Because, well, if both are wrong, would be an empty list. In the case of the maybe, it will be just a nothing, right? And if only one of those is the just, then, well, you just return the one that succeeded.
Oh, you're correct. Oh, it's because the name is terrible. Yeah, the name is terrible because plus and join, they kind of have the semantics that both parts will be there. But that's never the case, right, Nathan?
Wait, can you repeat the last part?
Yeah, because do you agree that the plus combinator that we are seeing on the paper will always return one of them, although you are concatenating them?
Yeah, in the way that you said, yes. Yeah.
So,
At least if it both doesn't fail, right? Because if that can happen,
no, but if both
then it's
fail,
going
doesn't
to.
matter in this case because the result is going to be an empty list.
No, no, but I mean, then it's not the result of one of those, right? Well, it is. If well,
uh, yeah, that's. Yeah, I think we can make it then. We just have to change the name. Join is really terrible.
but now it's the question: how do you want to use this to implement the thing that Mageta is doing? That's the fold.
No, that's the thing. They are completely
Those are
two.
two incompatible things.
Yeah,
That's what I was doing
exactly. It
different.
is. They are incompatible because why we want to use the fold? Because we want to make this variadic. Because the plus only accepts two parsers, right? What we were the intention of using the fold is to have a list of parsers.
Okay.
That's the first like major hiccup. The second major hiccup is that I don't know exactly how we're going to implement the match word without. Like I said, we're going to have to make to be creative because we are not using the same
So,
representation.
can I share my screen
Yeah, you can.
and try to do
Mhm.
something here?
Yeah, you can. Feel free.
Because let me see if I'm
I'm
sharing
going to
the.
have to think about not using
I'm
the same
doing my way,
representation.
man.
Wait, Mageta, but I want your input here, man. Uh, like,
Okay.
suppose we have a parser, right, for char, and what I'm
Hey, Willie.
thinking.
Man, in the middle of the bunch of vocamos, we're he's doing this.
Uh, it's the one that I have open here. But the thing is, basically, what I'm thinking is for the case we want, right? We have like parser of shards and we want to transform in strings and such. And it's naive, I guess.
Mhm.
So I have a parser of char, right? And I'm receiving the string. Okay. But that's the thing. If I use this string to match like one char, right, and return the rest of the thing like this, then I can take the parser B, right, and run on the rest, sure, and
Yeah.
do that with both. And if both succeeded, then I can just, how
Yeah.
can I say,
That's
concatenate
that's
the
what I
result
was
of
doing.
those because they
Yeah,
will
that's
not be
what I
to
was doing.
char. They are to char, but I will map them to return a
Yes.
list, but it will be a list of only one char, right?
Mm-hmm.
And we can literally just check those, like running the parser and see if it fails. And if it
Yeah.
fails, then everything
That's
is
what I was
wrong.
doing right now. Yeah.
Oh, okay.
That's what I was doing here. But I was doing like just mapping and getting a list out of these characters. You see? Can you see these two lines? So I am mapping the parsers, so I'm just creating them with the word, and then I'm just getting the characters.
Map X to match char X. That
Yeah,
is
and
doing
just
the
making.
parsing of char to
Yeah.
to a list of char that only has like one char.
Yeah, it's not really a list. This is just the shards, the satisfy. It doesn't need to be a list, by the way, because here the character, a string
No,
or a
yeah,
character is
Yeah,
already a
but
list.
that lambda XX is not transforming to a list of one char, by the
Yeah,
way.
this is just a character list,
wait, Mageta, if
which doesn't
you
need to exist, right? It can be just be.
but what you just said, oh, the char is already a string and such, and then we don't even need any kind of mapping because they already have the signature that we want, right?
Yeah, we just need to concat all the rest of the parsers. We just need to run them.
So it's really like a bind, but instead of
It is a bind, man. The implementation of this scrap in the paper is a bunch of binds.
but it's
So we
uh,
just run. Let me see. So we need to run.
no, it is
The,
not, Lemus. It's not exactly the bind, man, because you
to
are not.
run.
How can I say?
Think of the steps. Like we need to run each of them. No,
Yeah.
because the partial input that represents them. Okay, that's why I was doing the other thing. So that's the rest part that you were doing, which is you take, for example, the first parser, you pick the first position because you know it was like representative in order.
And you get a maybe, right?
Yeah,
And if
and
it's
then
nothing, you already fails. If it's an
so-
okay, then you have the result of that, the successful result, and the rest. Then you
so
input
let
the
me look.
rest to the second one, right? If the second one
Mhm.
fails, everything fails. If it succeeds, then you have two partial results, right? And then you just
Mhm.
concat them.
So let's see here. So it's a lambda,
Yeah, we are kind
then
of
the
doing implementing the
accumulator.
many, but okay. That's fine, I
Then
guess.
yeah, that's what I was saying. Like I didn't see the point of doing only one because it's also the many. But
No,
we can just
the point
remove
is,
this part.
man,
Dude, it doesn't
Margetta,
matter,
the
man.
point is
Everything
really
will be the
simple.
same.
We start from basic units and we start from there. We are jumping steps. That's what we're doing.
And I
That's
still
fine.
don't see the point of doing that. It's gonna end up being the same thing.
You are saying that, okay, that's a specific instance of the many, but it's not abstracted.
Yeah,
That's what
yeah,
you're saying. Oh,
yes.
okay.
We are like this fold can be totally like generalized into the many implementation.
Well, yeah, I don't know the general
I
form of.
think it will just be harder doing that than doing extreme go horse like
And
this.
also, Lemus, we can do the opposite of implementing instance and then abstracting, right?
No, 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 but I'm not against that idea. Actually, I'm not against any ideas in this case. We can do whatever we want. My suggestion in the beginning was, okay, what about making the simplest ones first, so that we can have a taste on how to do the parsers. And then we started. We had problems in the middle of the journey, and then
And
Magenta
making the
said,
simplest one
forget it,
started getting
forget it.
harder.
Let's just do the hardest one because I know how to
Lemus,
do it.
Lemus, I totally agree with you if we know already how to do the things correctly.
No, no, but that's the thing. It's not about that we don't know how to do the things correctly, Nathan. It's because we discuss and we disagree. That's the thing.
Mm.
And one of the problems is that the
Just
representation is
somebody just
fundamentally
nukes and
different.
start doing their own
The
stuff,
f-
right?
the f- the semantics, the modeling that the guys use in the paper and our modeling, they are completely different, completely different, completely apart. I don't even know why Namageta read this paper to do them. to do his
No,
parser combinator.
because the definition of the types is the same. The problem is like when he goes in the list construction. Didn't pay attention to that.
No. It's the types of the constructions. They are totally different, man.
No, they're not, man.
They are totally different, man.
No,
Totally.
they're not, man. They're the
They
same
are, man.
thing.
Where is
No,
the
no, dude,
list?
you're returning.
Point me.
Dude,
Where is the
no, no,
list?
dude. I'm not pointing about the list. I'm talking about the constructor of the parser is the same.
No, the idea of having a bunch of functions and composing them, I agree, that's the same. But some properties, they only in this paper they're only here because the final result of the type parser is a list.
Lemos, the only thing I can see that fits on that is the thing regarding being ambiguous, man. Because take a look regarding being a maybe, that maybe can be instead of a list, and regarding have different things that can be like concatenable. They only works for the list if the tuples have the same type. So in the maybe case, that's if the result is concatenable. So
No,
uh,
Nathan, I just want just go to Nageta, continue doing your thing. I'm gonna just explain to Nathan here. Go to
okay.
page 4. Okay? Page 4.
Just a second. Page 4. Okay.
Yeah, so the outer structure, which is a function, we have. We also the parser is here in our implementation is also a
Wait, but
string to something. That's
okay,
fine.
you are talking about the last definition of a parser A, right?
Yes.
Okay.
We have an input that is a string, and that is a function to something. The something in the paper is a list of tuples. Is that okay?
Sure.
In
Yes.
our case, our type is string to tuple only.
Oh, we don't have any wrapper.
Yeah.
Wait, don't we have a kind of a maybe because we are doing checks there
No,
on?
we are using a tag. We are using like kinda ish or like
A
a
tag.
tag.
No, then that's a
Literally a
result for me.
symbol. Literally a symbol.
Yeah, literally a symbol.
No, but then you have the symbol and the tuple, right?
We have it's almost like a triplet in this case because we
Dude,
have
Then that's
let me
result for
share my
me.
turn.
Like it counts as the result in this case. It's what we have, right? As a result.
yeah of
If you
of the
see my
paper.
cramp here.
The A of the paper is what we are calling here value. And the string, which is the remaining part of the input, we are calling that input here.
Wait, here where? Man?
Okay, go to line on Mageta's screen. In the Emacs, do you see line 18 up?
Yeah.
The first part of the input is the remaining input. This tuple is a triplet. The first member is the remaining input.
Okay.
The second is if it's successful or not, which is a symbol, and the third guy will be the value parsed. In that particular case, the input is also the value parsed, but forget about that. So do you understand that instead of having a list of tuples, we have only a triplet?
Yeah, but that's the same as having a tuple inside the result, man.
That's the same as having a tuple inside a result.
Yup.
How do you concatenate two tuples inside two results?
Yeah, the result needs to be concatenable, right?
No, but here we only have tuples, man. We don't have results, don't have anything. We have triplets. How you
No,
do
no.
concatenation?
Do you agree with me that let's call it a triplet, right?
Mm-hmm.
One of those being a tag, it's the same thing as a result. Can we agree on that?
Yeah.
So there you have it. If the result, the value when the thing is parsed correctly, that happens on the OK branch on the result, if that's concatenable, then the result is concatenable, right? Because if
No,
it's
yeah,
failure,
but we don't
then
know about that. We don't know if the inner value of the result is concatenable. We don't know.
okay. Now let's jump to the list that the guy's using, right? So the guy cannot just also do the same regarding, how can I say, any two lists. Why is that? Because the tuple that they have inside the list has a type and they need to be the same, right?
Yeah. But you need to imagine that the guy is making his own AST, so the type will be the same at the end of the day.
Oh, okay. If it's an AST, right? Then it's okay.
It's always concatenable in this case. Like we need to create this term in English, concatenable.
Maybe that's already a thing, man.
I never heard anybody
Con,
saying that.
concatenable. I don't know. It's something that you can concatenate, right?
Yeah, exactly. So
Uh,
in the A type, the parser A in the guy that is doing, he's gonna make his exactly as we are doing in the Spoon compiler. He will have his own
okay,
AST.
I got you. I got you in the sense that oh, it's AST, then it can have multiple options that any of those options receive a types, and they therefore they are all the same type.
Yeah,
Okay,
yeah.
I see. I see.
And in the beginning of the paper, he's using chars exactly because of that, because he didn't present yet the type system, like
Yeah,
the
but
AST.
can let me see. But you see that then they're responsible for the thing being concatenable. Wait. Oh, I
No, the
see.
types themselves, they are not concatenable at all, but because they are wrapped in a list, they are now.
Okay, you can do a list of them,
Yeah,
and that will not be a different time than they usually already are,
yeah.
right?
And
Okay,
then
yeah, I
that's
see the
why
difference.
then that's why the plus works in his case. But our representation
Oh,
is
that's good.
completely different in this regard.
Oh,
Yeah,
this is gonna
I
be
still
crazy.
don't think we should follow. Well, how can I say? I still don't think we need to do in the list case. I think you can really do without. Just I don't know different implementations,
No, like I
but
said, we can do
but
our
yeah,
implementation, but we need to be creative because we can't depend on the author.
but yeah, I agree with you that it would be more straightforward if we did the same.
Yeah. But Magetta did his parser combinator before, so I'm assuming that he will remember the tricks.
I did, yeah, but that's the thing. I didn't make stuff. I used for like shards and stuff. It was like the convoluted way, which is just like
Lemos,
I can show the code later. It's horrible.
Uh,
but you saw what the guy saying regarding the list, right? Uh, he said
Yeah.
regarding the ambiguous part. If that's the only case that he's using the list for, then we are completely fine, man.
no, but I don't
Because
know. I didn't read the rest. I don't know if the
yeah,
list is gonna be necessary in the other
for
cases.
something else, right?
Yeah. Because at some point he needs to define his type, like a sum type, whatever. It needs to be a monad, which is not hard. Yeah,
Oh,
yeah.
that's that's pretty cool actually. Okay.
Hmm?
So the zip actually wraps oh man like prologue okay like Erlang
Bro,
functions they have prologue. Erlang functions they can be weird but they are actually useful sometimes like this the zip
sometimes.
sometimes the zip is
No,
this so it's a
what I think
tuple
is happening is Magetta saw a function that is exactly a
that is
normal function,
exactly this.
what a normal human expects. Then he's amazed that Erlang is
Yes,
doing a okay thing.
yes, look at this, it's what I would expect. That's exactly what I should expect on a zip.
So TLDR is just a normal zip, but Erlang usually don't have just normal function, right?
Yes, yes, exactly.
That's the amazing part about it.
Oh no. That's
All right.
amazing.
So what was I doing here? So let me see. Unzipping parsers with this shit so I can run. Yes, that's right. So I can run. This is gonna be a beautiful line as you see. So we can run. We can increase a little bit more.
Wait. The what is the tuple in the middle? That's what I'm not getting.
Tuple in the middle. This dude. And just it's the base case. Oopsie. This is wrong. It's the accumulator. So
No,
it's just
okay.
the first position, which leads me to think that I should also chop the head out of here. But then I noticed that I don't have that power because, well, pattern matching doesn't work everywhere in this language because it's this
Yeah.
Lisp, it's not Erlang.
Wait, don't have any function that do the head? Don't have head?
No,
Head.
because you in Erlang you just do
What the no, no,
so.
that can't be right, Mageta. What the fuck? Really?
What is it? Was the excuse? I didn't. I didn't see it.
In Erlang you do that with pattern matching.
No, but that's a bad argument.
No, but that's the thing. Like they don't feel the need of having a function like that because it's just pattern match.
But then you don't have a function for
Probably.
head, and you
No, no,
cannot do
no.
the pattern matching for taking the head.
Yes, because well, I don't know if the pattern match in here how I can do the pattern match because the only case we know how to do pattern matching is in the argument of a function, which didn't work on a lambda. By the way, I tried.
Man,
Yeah, I
we
Ooh.
tried.
only have head function in a queue. We don't have it in the list.
Wait, but weren't you use some kind of case there? Oh, what was case, right? Not
Wait, what?
weren't you using pattern matching inside the function, like without being on the argument
Yeah,
somewhere?
inside a function, yes, but dude, I just wanted to get an element out of the head. Like I didn't want a
No,
pattern match.
right. So can't you do the pattern matching like inside the lambda, right? After the arguments?
Oh, good
I
idea.
I
For up,
can't.
for
No,
up. Do
but dude, you didn't get the problem. Here,
Okay.
I need an initial thing.
yeah. Line four. Can
Here,
you
it's
pattern
on the
match on line
wrong
four?
length
For up, sorry.
for up.
Yeah, instead of having word, you can pattern match right there. Don't can't you?
Yeah, that's the thing. I don't think I can. How can I
What?
do that? I
For
would need to
up,
do a
line four
case.
up, man. For up.
Oh, the word and but I need to pattern match the parsers as well.
Can't you? Can you rebuild a list having the head and the tail?
Oh man, what the fuck is this language?
Dude, like if I could do
We
this
wait.
here,
No,
something
not
like this.
there. Not there.
No,
Line three up now.
dude, I'm just saying I need to do this. So that's what I'm saying. If I could do this, then that will help.
Yeah, maybe you can
Because
do the
okay,
use the pipe
I
instead of
can
the
do
comma.
this, yeah, but yeah, I can do this, but whatever.
Lemos,
The
Lemos.
problem is like doing here as well.
The answer is we can do the mergement. We can, like, if there is no other way for you to use a head and a tail to rebuild the list, if there is no other way, then you can transform the head in a list using a literal list, right? And then use a merge.
Oh no, that would be.
Or we use the drop while.
Huh?
Drop
Wait,
while you drop the things that from the list and then you pass like I don't know length or something.
wait, what? No, wait. We're not talking about the same thing. I'm talking
Partition.
about. No, wait. I'm talking about the opposite, Magita. Like having the head and the list and rebuilding it.
Oh, okay, constructing it again, right?
Hmm.
Oh yeah, okay. We can have partition. We can just split the list. That's fine. Prefix
That's
returns
for
true
check.
if list 1 is a prefix of list 2, otherwise false.
Yeah, makes sense. The name is not bad.
Yeah, but what is a prefix?
What do you mean?
How many how many elements of the first thing match with the second? It doesn't make sense to me. What is the
It's
prefix?
the opposite of
See?
suffix.
Just the head? No, yeah, but what is the prefix? Just the head or two elements?
No, you control that using list one.
Wait, but how
No,
does
it's
help
just a
us
term.
to have a
It's a
boolean?
term.
What do you mean it's a term, man?
It's a term. It's a unique thing. It cannot be like I don't know first and second position. It's just a term. That's what I want to know.
No. That's the position you will never know.
But
You're
then
asking too
why is it
much.
comparing equals on lists and then equals to a list of term, man?
Yeah, that types
This
I can
notation,
understand.
this notation doesn't make sense.
Oh wait, can we click just for a moment filter map? Can you go to filter map?
Filter
Oh
map.
no.
I'm
Do,
wondering.
do you
He
really
probably
want to see
doesn't.
one of those functions?
Probably filters and map at the same time.
Yes.
Oh man.
Wait, look at the example. Look at the example.
True and value. The fuck?
It has an accumulator. Wait, let me read, man. Calls from a lane on successive elements a lane
Oh no,
of
no, this
list.
does okay, this is a normal filter map.
So this one is a normal Dude, this language is
Yeah.
very inconsistent, man.
It's a normal filter map, this one.
Wait, but wouldn't I need two functions for a normal filter map?
Not in normally yes, but in this case the function that you're passing to filter map is doing the both jobs at the same time.
So that's just a. Oh.
That's
Oh,
a
okay. I
tuple.
see. I see. I see.
You
The
return a
tuple that you are
tuple.
returning is really bad. Yes. Holy fuck.
Yeah, man. I wouldn't want to work with this language.
Yeah.
So, yeah, that was actually good for to work with it, to do something with it and suffer. I forgot what was I doing.
We were trying to discover how to take a head off a list.
Ah, no, never mind. Let's just ignore that. We can do that later. So I
Holy man,
want
it's already like
basically.
11.
Oh man, let's stop then. Oh yeah, 11. Let me just see what I was about to do